there are always time for us to have a fresh start. Anytime it's a time for us to have a fresh start. If you want to start your career, you're more than welcome to start. Even today is the proper time for you to say, oh, hang on a second, I want to take some step forward and do that. The same is true for all others who didn't get a chance to sit in front of a computer in their youth. Hi, guys and ladies. Welcome to my podcast. This is going to be my first episode in this podcast. My name is SMMEs. I'm a chartered developmental financial analyst. It's a financial analyst, but that specializes in developmental finance. I've spent almost 2 decades in banking. And over some time, I've always wanted to think that there's more to me than just being an analyst at the bank, and that's the why I created this channel. And lately, I have started thinking about taking the stuff that I was posting on my YouTube channel into a podcast. But over some time, I realized that I didn't have the proper gear, I didn't have the proper equipment. The sound was horrible. So this is going to be the first episode that I'm going to be putting in as a vlog on YouTube, and also I'm going to be putting it in as a podcast on all the podcast platforms. So the podcasts that were there before, I'm just going to take them out because of audio. And this is going to be the fresh start. So from now on, I might have to repeat some of the concepts that I've done before. But if you followed me on YouTube before, please forgive me. Some might not be exactly the same, but over time, I think both the audio people and the video people needs to get the same more or less benefit. Who am I? I live in South Africa. I was born in a province called Free State, and I moved to the province of Gauteng because of work, of school. I went to varsity. I did become finance, and then after become finance, I started doing some work for my brother's company where I started as an accountant, and that's how I got my job into banking because of finance. I was an assistant financial officer for some time, and then I realized that there's more to me than just just being in finance. I started going around in analytics, and what I wanted to do is to take a step back on this episode and just look at how did I actually get into data analysis. I had different positions along the way, but all of them was this big thing called data. And I had at one point this morning, as part of my morning routine, I had scribbled something that I ended up posting on a blog as an article, just for me reflecting on how did I get there. So at a time when I joined in, the need for analysis had grown so much over the years that the businesses really needed somebody else to start. So I started my data analysis career running away from what I said before, the debits and the credit of being an assistant financial officer. But over time, the whole world, I realized that there was much more attention being given to analyzing data, because we're now starting to have all this other data. I think at a time we still had iMates, and HTC was also coming in. So the smartphone platform was becoming new, and new insights were coming in. And to add to the mix, that whole thing of portable devices made doing everything easier, to a point that we started using them, and the companies wanted to know what are we doing, and so forth. It became just the need for data. We started to collect even more data as the whole world, and then that created a need for a better and faster way for us to do data analysis, and that's how I started my career. So I need to actually point out that at that time, everybody started who started with data analysis around those time, around the 2010s. um, they somehow still all remember just being pulled into a role. There wasn't something formal that says because you went to university you can start with this role type of a thing. There wasn't any formal training. There wasn't pathways like we see today, but we were just being pulled into a role. All that was important at a time was, selecting some diligent workers who are good at, operational data manipulation, and probably some softwares that they can work with here and there. If you were one of those employees, you were more likely to be pulled into a role, and now you've been thrown an analyst title. We all started being given different titles, from business analyst, data analyst, and in my case, I was a sales operations reporting manager. But before then, when I was in another bank, I was an activity-based costing specialist. All I was, just to put it in simple terms, all I was doing is to go into SQL, run some SQL integration services, SSIS, and then I'll push the data into SAS, and then we'll analyze whatever's coming from SAS. But because we were analyzing information that could definitely be used for transfer pricing, I ended up, doubling that role of moving from debits and credits and now going into the world of, data analysis and data, because that's what the people were doing. When they heard that's what I'm doing, they're like, no, don't waste your time. Just come join us in IT. It mattered not what our titles were at the time. We were all somehow managing data in different levels and in different ways. I recently went online and realized that the data field now has attracted many different people. There's people with different backgrounds from different know-hows. Others are still students, others are coming up. And some are even reaching out to me like on LinkedIn to say, can you be my coach? Can you be my mentor? Can you help me how to navigate all of this? And everybody is asking for the magic formula that is needed for one to become an analyst of data. Some advice out there, I must say, I went out and I looked at it. Some are there just for the views, because I know the fact that they won't make one to become an analyst. They are good to hear and listen. But as far as I understood how I became an analyst, some of them might not make it. And how I understand how I was helping to hire some of the analysts and the people in finance, I realized that some of the tricks that were given out there might actually lead a few people astray. Neither are the steps that I took, as at a time there was a need for everyone, even with mediocre analytical skills, to have a good career back then. But right now, some of the skills that are given, I mean, we taught to do hectic coding and do this. Your PC must be expensive, must have all of those things. And none of those makes any sense as far as I'm concerned. Because when we started, we were running a Pentium 2 or I had a Pentium, a Celeron 33 megahertz CPU. I didn't have this fancy hardcore machines that can run petabytes of data that people are asking. Yeah, run this day. I was running data on a floppy disk. That's how I learned on Microsoft Excel. Once you learn 10 records, how they go, it's easier for you to start going into SQL and visualize how 100 records would go, how 1,000,000 would go. They follow the same pattern. It doesn't matter. Really, for me right now, it's very difficult to see people being asked to double with big data algorithms, Python, R, you name them. And I'm thinking maybe we have evolved to a point that our hunger doesn't even get filled by a small beggar anymore. We need like a truck full of beggars just for you to become an intern in data science or data analysis. It really makes no sense to me. And more especially being on the other side where I've sat in a lot of exco meetings, I don't think we need all of this. But right now, one thing that I know that people are saying online, probably they're scaring you a lot, and you just need to take a deep breath, one or two, and then choose a field that you want to specialize on. And once you get that field that you want to specialize on, you might find yourself in a good career that you can, be able to flourish in that career. Universities at a time when I started didn't have, a formal training. Thus, right now we see a never-ending list of qualifications that you must do in data and whatever analysis variations in titles. For as far as I'm concerned, I just did one big data analytics. That was the closest course that was close to data. but I've never needed to analyze anything else that was big data. My records always stopped at few million records. They never went to hundreds of millions of records. If I had less than 10 million records, and I would know, I would optimize it that only maybe I get 1,000,000 or 900 records back. And it's always quite easy to, with averaging and aggregating the data, it's always made sense that simple technique that you use in Excel, I could run, most of the things and give out very good financial advice. Because, yeah, with my career, I'll explain it at one point. The big data costs, as far as I'm concerned, are the ones that I'm particularly interested in. This is when I bumped into a 5-pager that was created to assist anybody else to be a data scientist. And I was quite excited when I see this 5-pager. The document was well written with big fonts. That's why I was excited, because I don't want to be walking around with my glasses, put my glasses away. This ensured, the big fonts actually quite ensured that everybody follows the process that was written there. Although I soon realized that what was written on this document is like what you find in most social media channels or content. However, there is a need for this type of document, as we are all in different. We are not all in a same social media cycle, because we are all in different social media cycle. I think at one point somebody has to come in and pull in to say, as far as data analytics is concerned, I think this information makes sense. All of us might be fighting to say no, but that's not the golden rule. Because as far as I'm concerned, when it comes to data and becoming an analyst, there is no golden thread, there's no golden rule. Anybody's got their own how to. But as far as I'm concerned, it's much easier to always mentor or seek a coach that has been who has practiced in the data analytics for quite a while. I would say a decade, but right now I think a year is good enough. The world is changing so fast that my almost 2 decades in banking, I mean, could easily be replaced by somebody else who's been practicing for a year, if they're very good at it, because the computers can actually teach us much faster and quite efficiently compared to us sitting in a role for quite a while, because most of the time we start doing repetition. So right now, I'm not going to go through all the steps that I found interesting in how you become a data analytics, or specifically a data scientist. But I'm quite interested in 3 or 4 things. The first one is the need for having mathematical fundamentals. Mathematical fundamentals are very important. It's always encouraging, much especially for me, to see that most of our school living here in South Africa, when they go through their matric, that there are learners that are still taking math as their last year matric, passing. But I know that there are different people that has got different aspiration, and we all aspire to become in the field of that requires maths and science. And given the complexities that we are facing right now, I mean, it makes sense that we all try our own luck. We go out in grade 12, and hence why others, opt out of maths and science subjects right here in South Africa. And they can probably get discouraged when they see all of this, and they're like, oh my gosh, why would I want to do math and science? Let me just opt out. If you're one of those that opted out and chose otherwise, do not be discouraged or do not be distressed. There are various resources right now online that can actually help you get yourself into the mathematical type of thing. There are very, very good online resources. There's a guy that I met earlier on this year. He's doing a channel for math and science. I think he's doing very well. His viewership is growing quite well. I think he's doing very, very well to just teach people basics of maths and physics and whatever. And I think you can take some of those just for you to have math fundamentals. You don't have to finish up the math fundamentals before you start with you being in data. You can still have it concurrently. And when I'm talking about the math fundamentals, I'm actually talking about the need for us as aspiring analysts or you as an aspiring analyst, to actually understand the concepts of linear algebra, calculus, maybe optimization, and a few functions to say, how does this function work? Don't worry about having like well-to-do knowledge about those things. You don't have to get a PhD or doctorate equivalent in this concept. All I just want you to do is just to get yourself introduced to them. Once you are introduced to them, maybe we can talk about the next step. All you have to remember is you're learning math not to do it on paper, but you are learning math so that you understand what the software should be doing to get you to where you want to go. So as much as you are going through the learning, just learn the concept, not do all the problems that are there and try to get all the answers right. That's what we used to do in high school. But right now, learning to be a code and analyst, you don't have to, because we know as people that are employing, and EXCO also know, which is the executive committee, they know that all you need is somebody who can be able to take some commands, give them to the computer, the same computer that the ESCO has bought, and then come out with very, very good results. If you can do that, I think you're quite good. So the first thing, which is the math fundamentals, I think they're very, very important. The second one that everybody is talking about is now learning how to program. And learning how to program, I'm gonna try to explain it a little bit to say why is it important. For me, actually. So learning math concept, it helped me at how somehow be able to know how the computer will be translating what I'm trying to give it, whether it's words or whatever the case is, how that it helped me with the math so that I can know how the computer will be doing. And I would like to put this as equivalent to using a calculator. You remember at the time, I don't know if you used to do that. I used to try to do my math in my head. That's what I was taught in primary. And then I would do my math in my pen. That's what I did in high school. But I think at what point we got introduced to this thing called calculators, especially they became even more complicated, like financial calculators and stuff. So the steps that you normally take in learning how the calculator operates is more or less the same as learning how the computer operates. With a financial calculator, we have complicated things like amortization or net present value or internal rate of returns. On paper, it might take me a few steps to write it down, but if I know the right right buttons to punch, I could get an answer within seconds, and the calculator will help me with that, and I can move on. So if you're thinking about scribbling down, you don't have to. So if I use that analogy to say it's more or less the same, when you learn how to program your computer to say this program will run this way, it's so that the computer could help you the same way as the calculator used to help us with mathematics. So on my side, I when I enrolled for my second degree in IT management, that's when I got introduced to coding. But when I did the coding, I did the basic one, and people will be like, that's not data science or anything. I did what is called Visual Basic, which is VBA. Visual Basic, I think, is the easiest programming language there is. It has its own framework that you must follow so that the computer could understand what you want, those commands. But it's the easiest one. And the data one that I've learned was not Python or R or anything. It was SQL. Microsoft SQL is the one that I doubled with. And I use the SQL, the structured query language, SQL, that's what it stands for. I used that first in Microsoft Access. And then from Microsoft Access, then I was able to move it into Microsoft SQL Server Manager, and that's how I got into it. The thing that's closer to data science is when I took my big data course in postgrad. That's when I learned, all those things about Venn diagrams and complex statistical things. But as far as those are going, I think there are more options right now for self-study than at a time. I didn't know what was I gonna need those things for, because as far as I'm concerned, I have never gotten into, in my 20 years, almost 22 decades, I've never gotten into a point where I'm required to be running all those k-means complex algorithm. Others will say yes, because you fell off, you are not in data science. I agree, I'm not in data science, but I was in data analysis for quite a long time. That I've never seen the need for that. Unless if you're going for a small niche, which is normally a handful of people in a big organization, which are data sciences, then you can actually think about advanced statistics. But as far as I'm there, I think learning programming language and starting with just the basic, just to understand how the computer works, I think you'll be very, very in a good space. But also the nice part about it is a lot of people are solving how to learn how to code. So it's becoming even easier for you to learn how to code. Other people out there are suggesting that if you learn Python, probably, and CS fundamentals, you might yield better result as a data science. I do not know as far as that much. Instead of me progressing my career and being super in data, I started going into the analyst route, where I moved from financial analysis, strategy analysis, and I started going more towards the business route, not towards the hardcore data analytics or data understanding route. So the third thing that I just want us to talk about in data language is called data wrangling and visualization. But essentially, what this means is the ability to learn how data could be, shown, and all of this comes in when you learn how to code. And if you learn how to code, you can actually assist with data wrangling. Data wrangling techniques includes probably data collection, data cleaning, and data exploration, because at one point we still need to understand those three steps. These steps are really important. If you find yourself as a data scientist, and you get data and you haven't gotten any data analyst or data engineer who has done these steps on data before you get it, so it's quite important that you also quite learn how to clean up or find meanings in your data. They are very important to on that case. And you might be appointed maybe in a project where it's only you, there's not a lot of people, and it's only you who's supposed to be looking at that. No data engineers, there's nobody else, like I said before. And then you have to learn all of those things. Data visualization also on the other side, as much as data wrangling, data visualization will help with data storytelling. I know when I talk about storytelling, most of us, we already thinking about walking into a boardroom and saying, this is the answer. But the data storytelling is a story that says what has happened to data. Say, for instance, you're starting at the beginning, you had so many records, there were duplicates, you took them. That whole story, you just need to show it in a proper story to say what have happened to the data along the way until it got into a point where we are looking at it. So I think that whole thing to say what did you receive, what did you clean, what did you remove or truncated, yeah, show us where the duplicates are before we even start with our analysis. I think it will quite help. And if you can do that nicely visually so that people can actually see that we sent you 7 million records, there we can see how the 7 million started and how they start filtering out until you only left with 20,000 records because of all those filters and all of those steps that you'll be taking. The next one, which is the last one, is statistics and probability. This, I know I'm trying to pull you in. I don't know about you guys, but I'm taking you back to varsity. Another way to keep, I think, your audience engaged is by showing those statistical things and probability. The best way is to learn how to conduct, I think, descriptive statistics as far as I'm concerned. I do descriptive statistics most of the time on my data just to let my audience know what is the minimum amount. So for instance, we're looking at salaries. What is the minimum salary? What is the maximum salary? What is the average salary, the mean? What is the mode? What is the one that's repeating itself? Stuff like that. So that they just know more or less what is the population. So you don't have to bring 2 million records. You can just do in a small table to say, what is the lowest amount in that column? What is the highest amount? What number repeats itself? Maybe people are earning 10,000, all of them. All of that, just that descriptive thing. If you can learn how to do that, I think you'll be in good stead. There are other statistical concepts that we have learned also in first year. I don't know about you, but if you haven't gone to varsity, don't lose hope. All of this, you can get them online. But the only thing else, you might need some guidance to say it with pacing. There are other concepts which are very useful, and this includes inferential. It's been a while. It includes inferential, associative, and differential statistics. Probability is extremely important, as I learned the hard way when I did my master's, that I needed to do, put in probability and stuff like that. And it went to bite me in my dissertation and my thesis, but I soon got to do that. Conditional probability and the Bayes theorem could do wonders on your side if you can learn them, how you do that. Especially, around probability, you'll get wonderful results. But luckily on my side, I was not left alone when I did my thesis. My supervisor was there to guide me with the correct algorithm that I should be taking. And I just used the software, which was SPSS and SES, and I think NVivo for qualitative data, that I was able to get my results out there. And on top of that, I was able to get the descriptive information to say, this is the information that I got. This one algorithm show that the information, we can trust it, which is more or less what data scientists are doing, just to give us, confidence that the data that is there is not tampered. There are algorithms for that. And I think with the proper guidance, you can get somebody else who can help you to learn how all of those things are done. But for me, I think SPSS and SES could do quite wonders on your side. Just in conclusion, just to conclude this first chat that we're having on a podcast, I think learning math at school, it's a little bit daunting. I remember I didn't get the best marks, but to add to the mix, it does not mean that for those who do not have not done math when they matriculated are left out, or does it mean that those that did math has got the monopoly on becoming data analyst or data scientist career? There are always time for us to have a fresh start. Anytime it's a time for us to have a fresh start. If you want to start your career, you're more than welcome to start. Even today is the proper time for you to say, oh, hang on a second, I want to take some step forward and do that. The same is true for all others who didn't get a chance to sit in front of a computer in their youth. I know those that actually started with a computer when they were young have got a competitive advantage in terms of they know how to code earlier than the rest of us. But if you didn't get a chance, don't stress. It is not game over as yes. You can still learn how to code today as much as they did learn how to code in 1994. And also on top of that, I think learning stats and all of those things is extremely beneficial nowadays. I love knowing ways that to get the quick answers. I know I'm that lazy, and I think that learning stats could actually help you and your audience get to a way of doing quick data, quick analysis, and keep them engaged, especially when we're talking about data, because data could be quite boring sometimes. But once you get to the data talk and you show them how it's been done, I think it could be quite nice. There are frameworks we should aim to know when it comes to data. And I think if you allow me to think that, data wrangling and data visualization are some of the frameworks that are quite out there that you can easily pick up on, and they can help you, get your data story and your data mindset right the first time ago. So this will be my first podcast, guys. If you like this, please keep comments coming. I'll make much more where I'm actually breaking down how did I get there. And before you know it, we'll have quite a nice community that gives back to each other. Thanks, guys, for tuning in. Just stay tuned for the next episode.